All right, so this is 1.3. It's simplifying square roots. So if I take the square root of these numbers, the reason I write it like this, and I know a lot of times you see it where it's the other way around, where it'll say like 1 squared is 1, 2 squared is 4, 3 squared is 9. But I like the hair in my mouth. I like to write it a different way. Why do I like to write it a different way? As like backwards. So show you the square root and then show you that number. Because I cannot even tell you, and even in first period, I saw it again. So every time that I do this, every year, I have kids who end up saying the square root of 16 is the square root of 4. So don't do that, okay? You just want to turn it into 4. Those are the special cases. These perfect squares are the special cases where you can get rid of the square root, and that is your goal, is to have as little, the numbers as small as possible under the square root. But just remember that. You don't have to split the square root of 16 up into square root of 4 times square root of 4. It can just be 4, okay? Because I've just seen all sorts of stuff today. But all right, let's simplify some square roots. You will need a calculator. Hopefully you still have it. The square root of 36 is 6. Yeah, if you put it up, go grab it. Because we're like using it the whole time. The square root of 36 is 6. So it is important to know these perfect squares, because then right off the bat, you can realize, oh, I'm done, and you don't have to go through the whole process and all the steps of solving. So I just threw that on there just to point that out. This one's square root of 8, so we're starting simple. You are trying to find the largest perfect square that is a factor of 8, or multiplies evenly into 8. So things that are not allowed here. Decimals are not allowed. No decimals. Can't do it. So we're going to do Pythagorean theorem tomorrow. No decimals allowed. I know you may have in the past learned Pythagorean theorem by typing it in the calculator, taking the square root, and you end up with a decimal. You want exact answers, no rounding, no decimals, okay? And the way to do that is by simplifying radicals. So 4 goes into 8. 4 is a 4 and nope, not 2. 4 and 2 go into 8. 4 times 2 is 8. So you're splitting this perfect square. So the square always write the perfect square first. Always write the perfect square first. Number oh, yeah. All right, so 4 is written first, and 4 times 2 is 8, and then the square root of 4 is 2. So you have successfully now simplified the square root of 8. All right, you find the largest perfect square that goes into it. You split it apart with whatever number gets multiplied by that perfect square, and then you simplify this perfect square, and then you are done. Those are the steps in how you follow this. So like 50, some of you guys can look at it and know the perfect square. If you can't automatically look at it and know that 25 goes into it, I will show you a strategy using the calculator to find that perfect square. But for this one, it's pretty small. So 50 goes into 25, or multiplies into 25, or sorry, 25 multiplies into 50. It is a factor of 50. How many times? Multiplies in twice. So you split 25 and 2 up. You write 25 first. Square root of 25 times the square root of 2 still equals the square root of 50. We haven't actually changed anything, all right? We're just simplifying. And then the square root of 25 is 5. I don't know why I wrote 5 twice. You're just bringing the 2 down. Does that 2 change? Absolutely not. Stays the same. You can't do anything with that 2, because the only thing that can be simplified is that perfect square. Okay? And then I've had the question before of like, how do I know that I'm done? Like, when do I know that I can stop? You can stop when there's no perfect squares that multiply evenly into the number inside the square root. That's when you know to stop. If you get to 6, nothing can go into 6. No perfect squares can multiply evenly into 6. 10. No perfect squares can multiply evenly into 10. 11. 13. 15. There's a lot of numbers that don't multiply, don't have perfect squares that multiply evenly into it. All right, we get to 175. Some of you can look at that and think, oh, 25 goes into it, but maybe not know what the other factor is. So let's look at a strategy to find that perfect square. And so a way to do that is to turn your calculator on, click on y equals. So if you guys will do this with me. Okay. Click on y equals, and then you have the chart. And you're going to type that number, whatever that number is, not under the square root, just the number, 175, and then divided by 175 divided by x. All right, what is x? How do you find that? It's next to the green button. There's a little x there. It's right there. So 175 divided by x. And then your next step is going to, everybody have that? I'm going too fast. You're going to click 175 divided by x, and then second graph. You're going to pull up the table. And then your goal is to find that perfect square in either column. A lot of times it will be in the blue column. Unless it's 4 or 9, then it could be in both the blue and the black column. But you're looking for whole numbers first, and then whole numbers that are perfect squares. So like, both of them have to be whole numbers, but one of them has to be a perfect square. So if you look at 5 and 35, you're like, yay, both whole numbers. But neither one of those are perfect squares. They're not on our list that we highlighted up here. So that does not help us. We must move on from that. Then we look down and we're like, oh, 25. 25 goes into or multiplies evenly into 150 or 175 7 times. So square root of 25, square root of 7. Notice, even though it's written 7 and then 25 on this list, we're still writing the perfect square first. All right, and then that perfect square simplifies into 5. And you're done. How do I know I'm done? No perfect squares multiply evenly into 7. All right, I'm going to pause and let you do that strategy for this problem right here, number 5. But yeah, so 2 ways to do this. There's a shorter way and a longer way. Make sure you always find the largest perfect square. You may have just skipped across that, and some of you may have used 4 and 18 and then had to do the process again, just like this one. But I'm just showing you that life is a lot easier and it's a lot shorter if you use the largest perfect square. All right, let's move on. Yeah, do you have a question? You stretching? All right, let's move on to 216 divided by x. All right, so if I look on that blue side, I'm like, okay, I don't see any perfect squares until I scroll down, and then I get to 36, and I'm like, okay, this is going, 36 is the largest perfect square. So 36 and 6, that's how I split it apart. And then how do I know that? Because they're right next to each other. These are the 2 factors. 6 times 36 is 216. So 6, square root 6 is what you end up. So hopefully we're like starting to see the process. You've split it into a perfect square and another number. Simplify the perfect square. You're done as long as it's the largest perfect square that multiplies into it. All right. These get a little trickier, but they're really not too crazy. We have 150, which 150, 25 goes into it 6 times. I'll just tell you. But you also have this coefficient of 2 in front. So if 2 is that coefficient, you are going to just bring that down. Don't change it. And then 25 is your perfect square. That goes in to 150 or multiplies by 6 to equal 150. So 2 times square root of 25 times 6. There's a lot going on here. Bring the 2 down again. Simplify the square root of 25 to 5. Bring that square root of 6 down. All right, don't forget the square root there. But also make sure that square root disappears off the 5. I see people bringing down that square root, and I'm like, that's wrong. The square root of 25 is 5. All right, and then your last step is make sure you don't add those. I see 7 root 6 for something like this a lot. But is there a plus sign? No, don't be making up plus signs and add them in there. It's you multiply them together. We're multiplying all day here. So 10 root 6. We're done. All right, the easiest way to do these is to multiply them together and then simplify. So the way we do that is you only multiply the things that match. So 2 times 4 is 8. 27 times 6 is 162. So notice that the 8 stays out of the square root, just like the coefficients that it got multiplied by. And the 162 stays under that coefficient there. Now we can simplify. So we type y equals 162 divided by x. Go to our graph. This is a fairly easy one because 81 is a big perfect square. And it goes into this evenly. So 2 times 81, sorry, no, that's right, except that's wrong, the way I wrote it. I got it, I don't know, I'm going crazy here. Don't do what I just did. The perfect square is written first. That was weird. So 8 times square root of 81 times the square root of 2. So erase that if you copied my mistake before. 8 times 9, root 2. The root 2 can't come out of the square root. The 9 can, because square root of 81 is 9. 72, root 2 is your answer. So try to follow that process. Okay, I'm going to have you work on this one. I'm going to try to get around everybody to look at your answer really quickly. But if you have answered this problem, go ahead and get your Chromebook out and go to Delta Math.